Hello everybody, this is Radha Mogla. Today I am going to present our paper Transliteration from English to Telugu using phrase-based machine translation for general domain English words. Aim of this work is to develop a transliteration system from English to Telugu. For this purpose, a simple phrase-based machine translation system is trained for transliteration using open source toolkits Moses and Giza++. Machine transliteration techniques are often used in machine translation for translating out-of-vocabulary words and named entities. Machine transliteration techniques can also be used to study the pronunciation of the source language. Correct pronunciation of English words often causes problems for non-native speakers. The major difficulties arise due to the diversity of pronunciation of letter and grapheme. As a result, often the same letter or sequence of words are pronounced in different ways. For example, in the word advantage, letter A appears 3 times with 3 different pronunciations, and these pronunciations can be described with 3 phonetic symbols A, and E. Transliteration of English words to the reader's or learner's native language or mother tongue can help in learning the pronunciations of the language, as the output will be English words written in the language known to the reader. Here are some examples for different language pairs. For example, English to phonetic symbols, English to Hindi, between English and Hindi, and transliteration-based text input methods for Telugu. For Hindi and 7 Indian languages, between many Indian languages, and for English to Hindi and English to Telugu. Transliteration related work for English to Telugu is mainly done for named entities. If done for general English words, a pronunciation dictionary is used. However, in the present work, transliteration for general domain English words to Telugu is the focus. We attempt to achieve the same by considering the diversity of English pronunciation in database creation. Challenges faced in transliteration from English to Telugu. First is difference in number of alphabet. Because of the difference of number of alphabets in source and the target language, one-to-one character mapping cannot be done. At times, there are cases when the intended English sound is missing in the target side. For example, in the word leisure and fine. Presence of silent letter in the source language. In English, there are many letters which at times are not pronounced. For example, in the word comb, handkerchief, and should, letter B, D, and L are silent letters. Diversity in pronunciation associated with the letter or grapheme in different words. For example, the grapheme SW has 2 different pronunciations in the word swan and sword. Grapheme SC has 3 different pronunciations in the word seen, conscious, and skeptic. Pronunciation of letters on their position in a word. In English, the position of a letter sometimes decides the pronunciation of the word. For example, letter E when it is the last letter of a word and letter P when it is the first letter of a word sometimes remains silent. Database creation. After observing various English words and the sound associated with them for British English using Oxford Advanced Learners Dictionary, a parallel database was created. Some grapheme and letters were identified which are commonly used in English or are unique or have more than one sound associated with them depending upon the word they occur. This dataset contains around 2,200 unique words. Few examples of the grapheme considered during database creation are CH, EO, TH, TION, etc. 15% words were selected randomly for tuning and the rest of the words were used for training the transliteration system with 26 English alphabet, 25 special symbols, and few contractions. The testing dataset was prepared by using the words given in Nation ISP 2017 And by using the IPA-based phonemic transcription generated by Two Phonetic website, this dataset contains around 9,994 words. Few words were common in both the datasets. Segmentation and training of the transliteration system. Before training a transliteration system, segmentation of the words into small units of letter and grapheme is an important task. For the present work, this is done by 3 different methods, and for each method, 2 different transliteration systems were trained using Moses and Giza++. The first segmentation method segments the source side on the basis of the grapheme in the letters identified during database creation. The target side words were segmented into various target side grapheme irrespective of the source side grapheme. In the second method, the source words were segmented after a vowel if it is succeeded by a consonant. Similarly, the target side words were segmented after a vowel or vowel modifier or a full consonant if they are succeeded by a consonant. In the third method, source and target side words were segmented after every character. For target language, each modifier and half consonant were also considered as a single character. Here are the few settings used with Moses and Giza++. For experimental setting 1 and experimental setting 2, Ken-LM language model was used with order 5, and in experimental setting 2, Ken-LM was used with pruning of singletons of order 3 and higher. In both the experimental setting, alignment of source and target graphemes in letter was done using Giza++ with different alignment heuristics. Reordering model was also different in both the experimental setting. In experimental setting 2, good Turing discounting was used in training, and operation sequence model was also used in experimental setting 2 during training. Tuning of trained weights was done using minimum error rate training and batch mirror tuning with experimental setting 1 and 2 respectively. Decoding for the test set was done after filtering the phrase table for the test set using default settings of Moses with both the experimental settings. In experimental setting 2, the distortion limit was set to 0. After running the steps discussed earlier, the obtained output for the test set were Telugu words segmented by letters or grapheme based on the segmentation method with which these experiments were done. To convert the output into proper words, following steps were performed. A. The gaps between the letter and grapheme were deleted. B. For output generated with first segmentation method, some script-specific post-processing was done. C. For outputs generated with all the segmentation methods using both the experimental settings separately, if the first letter of a word is a modifier, it gets converted into equivalent vowel. Extraction of best transliteration by combining the top 3 transliterations generated when the dataset was segmented with 3 different segmentation methods. First of all, step A and B was applied. A weight of 3, 2, and 1 are given to the transliterations based on their ranks. On the basis of these weights, the frequency of the obtained transliterations are calculated. The transliterations for a word having the maximum score is extracted and is considered to be the best transliteration. If 2 output transliterations for a word have the same score, then the transliteration having the highest Moses generated score is considered to be the best transliteration. After that, step C is applied. A modified edit distance for accuracy check using the pronunciation of the target language. In MED-based evaluation, the cost of insertion, deletion, and substitution was set from 0.25 to 2.5 based on the letters deleted, inserted, and substituted and their position in a word. This was done by considering some of the letters in Telugu as phonetically similar letters. Here are the accuracy in terms of word level exact match and mean F score for transliteration system with different experimental settings and with 3 different segmentation methods. It was observed that with segmentation method 3 and experimental setting 2, the highest word level exact match was obtained, which was 40.41%. After extraction of best transliteration by combining the top 3 transliterations generated with different segmentation methods, with experimental setting 2, highest word level exact match was obtained, which was 43.07%, and the mean F score was 0.885. Percentage of words considered correct or phonetically similar transliteration having modified edit distance between 0 to 1 after extraction of best transliteration by combining the top 3 transliterations generated with different segmentation methods. It was highest with experimental setting 2 when modified edit distance was considered less than or equal to 1. It came across 61.84%. The size of the test data mentioned in some papers for English to Telugu transliteration is very small, for example 200 words or 850 words. In the presented work, the test data was large, almost 4 times the size of the training data. In spite of that, the accuracy obtained is quite significant. Out of 9,994 words of the test set, 8,966 words were not in the training data set. The outputs are generated without using any pronunciation dictionary matching. With these conditions, the system is giving good accuracy. So it can be concluded that construction of training database is extremely important for designing a transliteration system. These are the references. Thank you.